We begin by looking at the first problem, the profit made on a concert is related to the price of a ticket in the following way, and we have the graph of a parabola. I know that because I have an x squared. This one has the 10,000 factored out. Now you can use a graphing calculator to assist, and I'll show you these graphs on a graphing calculator, but sometimes I'm going to try to do this not on a graphing calculator, like with number 1. I can do a pretty good sketch with just kind of some basic math. If I actually rewrite this as p of x equals negative 10,000, times x squared minus 10x plus 24. I should be able to factor that polynomial with just some basic algebra. I would get x minus 6 and x minus 4, meaning that my zeros, or my x-intercepts, are 6 and 4. I should also know what my y-intercept is just by looking at the original polynomial. If I plugged in 0 for x, I would get 10,000 times negative 24, or negative 240,000. Finally, if I wanted to look for a maximum point, I could go halfway between the two x-intercepts and say that what is p of 5, because 5 is halfway in between the x-intercepts. Plugging 5 in gets me 10,000 times, I'm going to see the original one now, negative, that'd be 5 squared would be 25, plus 50 minus 24, which is 10,000 times, that would be 50 minus 49, so 10,000 times 1, which is 10,000. So the vertex occurs at 5, 10,000. So if I put all this together into a little sketch, as best I can, I know that somewhere down here at negative 240,000 is my y-intercept. Now this isn't going to be drawn necessarily to scale, but that's going to kind of come up and come back down. And so this occurs at x equals 4, this occurs at x equals 6, and this is the ordered pair 5, 10,000. So knowing what my variables are, x is the price of a ticket, and p, or in other words y, is the profit. It says what ticket's price would produce the maximum profit, $5 per ticket, because that's the maximum of the parabola. Okay, let's graph it and check. So I'm going to use the Inspire because it's a cooler calculator, but I'm going to go 10,000, and you guys can use your own calculators, times negative x squared plus 10x minus 24. And then I'm going to reset my scale to be up to, let's do 15,000. And if I look at this and kind of reset this to be like maybe 7. Oops, 7. It's my x max. And my y min, let's make like a negative 1. Okay, that's good enough. And then if I do my, see on this one I'm going to do a maximum. That for you guys, that's second calc 0. Left bound, right bound. My maximum is at 5, 10,000. So that's correct. Okay. So for most of these, you will have an option of using your graphing calculator, but I just want you to be aware that you don't necessarily need it. You can do all this math by hand if for some reason you're panicking. Number 2, the daily profit earned by the Weldon factory is related to the number of cases of candy canes produced in the following way, where P is the profit and X is the number of cases of candy canes produced daily. Find the number of cases of candy canes to be made daily in order to maximize the daily profit, and what is the maximum profit. We're going to practice this one just putting this straight in your calculator. So keeping in mind that X is the candy cases, and this is the hardest part, is just knowing that X is the candy cases and P is the profit. So you know which variable means what. So I'm going to go calculator. Let's minimize that. Let's put a calculator document in here. Let's put a graph in. And I want to do negative x squared plus 160x, and you can use this time to get your calculator out and plug it in yourself, minus 3400. You should be trying to figure out where your window is, and as you can see, I don't really see anything here. Let's make sure that I got the equation right. Yep. My y-min is at negative 3400, and this is also a downward parabola. So let's expand our scales a little bit. If I were to factor that, I'd be looking for factors at 3400 that differ by 160. Let's maybe make my x max be something like 500. And I can edit my x max directly on the screen here. So, oh, there's 5,000. That's too big, but at least we see something now. Let's go 500. Okay, so 500 is good. Let's cut it down to maybe 200. And let's take my y max up much higher. So let's take that up to 1,000, maybe. It's not high enough. So let's go 5,000. Too high, but that's okay. At least I see it. Let's drag this up here, and I can see the graph. And then what I want to do is a maximum. You guys would do second calc max. I'm going to go menu, analyze graph, and maximum. Left bound, right bound, and I've got a maximum of 80, 3,000. So my max point, or my vertex, is 80, 3,000. This could be work that you show, just showing you got the point. And then it says find the number of cases, so that would be 80 cases. And then what's the max profit? We can say for a max profit of $3,000. Number 3, Stacy stands on the roof of a building. Here's Stacy right here in this little figure. She throws a ball upward. The ball travels according to the equation S of t equals negative 16t squared plus 64t plus 60. Those of you in physics will recognize this equation as the one with feet, not with meters. With meters, it's negative 9.8 meters per second squared. But with feet, it's 16. S is the height, and t is the number of seconds. So we're going to hit the ground t seconds after it's thrown, and we have a parabola here, modeled by this equation. How high does the ball travel? If I did not have a calculator, I could start factoring, but since we do, let's just do a calculator on this one. Negative 16t squared. I'm actually going to pause this while I entered, and I'm going to press enter, and we get something looking like this. You'll notice that on my graph, the window resets every time. With you guys, you're going to want to go to the zoom standard menu and reset your window. Our max, if I plug in 0, my y-intercept is 60. So I'm at least going to want to go taller than that. Maybe let's go up to 200. And, okay, that looks okay. It's good enough to see what's going on. I might adjust my x-min just to be something a little bit like negative 3. And then take maybe that to 150. And take that to 6. And so I see a little bit more of the graph, but really it's not that necessary. I'm going to go to my window here so you guys can clearly see what my window was. Here's my window, x-min, x-max, y-min, and y-max. Really that's negative 6 2/3. You can change that to whatever you want. So there's my window. And I just want to do, let's see, it wants to say how high does the ball travel? Well, if I move this over here and I see, okay, so that's really what's going on. You can see that that matches the figure here, and you got a little person there. How high does the bar travel means I have to go menu, analyze graph, maximum, get a max point. And so the ball travels to a maximum height of 124 feet. So that's 124 feet. Now, she's standing at 60 feet. And how many seconds does it take for the ball to hit the ground? That's our x-intercept here. That's the t value of that. So I can look back at this graph and do you guys would do second calc roots, and I'm going to go menu, analyze graph, or sorry, zeros. You guys would do 0. So it's this, left bound, right bound, and I get a 0 here at 4.78, comma 0. So we can say part B would be about t equals 4.78 seconds. How high above the ground is the ball when it's thrown? Well, that's where she's standing, and so she's standing at 60 feet. 60 feet, aka the y-intercept. If I look at the graph here, here, I can see that that's actually my y-intercept. I could even ensure that it is. You guys would do second calc value. I would do when x equals 0, y is 60. You can look at the bottom right and see that right here. 0, 60. Okay, oops. Anyway, that's that one. Let's move on. Number 4. What two numbers whose difference is 104 will yield a minimum product? Is there a maximum product? Explain. So two numbers whose difference is 104, let x equal the first number. And if the difference is 104, we can say x minus 104 equals the second number. And the product, actually we'll just say the product p of x equals x times x minus 104. Well, this one shouldn't be terribly difficult to do without a calculator. I know that my two zeros for that function are 0 and 104. Remember, we also call those critical values. But those are my x-intercepts. My y-intercept is also 0 if my x-intercept is 0. So if I kind of look at what's going on with this graph, it's going to be a right side up parabola, an up parabola that's going to do something like this, with a minimum somewhere right there. Well, halfway between the x-intercepts is the point 54, or right here that would be the point 52, because this is 0, and that's 104. And if I plug 52 in for p, I get p of x equals 52 squared, 52 times 52, which is, let's just do it over here real quick. Be 104, 016, it'd be 2704, which is the maximum product. Or sorry, the minimum product, not the maximum product. Then it says, is there a maximum product? Well, let's kind of graph this here on the graphing calculator for a second. This shouldn't take more than a sec. Let's do a new graph. I'm going to go x times x minus 104. Let me pause and figure this out. Okay, why don't we put a dot in between there? I know that the max was 104, or the other x-axis was x-intercept was 104, so let's go 120 there. My minimum product was 2704, so let's go. Let's go negative 3000. And let's do a menu, analyze graph, minimum, left bound, right bound, up negative 2704. Oops. Which is correct because this should have been a negative 52 here if I plugged 52 in for there. So then my minimum product is negative 2704. Okay, that's a good check to do. This is the ordered pair now, 52, negative 2704, as you can see by the graph. The question now is there a maximum? Well, I would say no, and I hope you would too. So if I look at the right side and the left side, this parabola is going to go on forever. So there is no maximum. So we can say the minimum product is negative 2704. There is no max product because as x goes to infinity, p of x also goes to infinity. And we could also say it the other way too. As x goes to negative infinity, p of x also goes to positive infinity. That goes back to the discussions we were doing last chapter. But Okay, next problem. Suppose a farmer wants to set up a rectangular fencing scheme. And in addition to suppose that the strength of prevailing winds, farmer must use the fence that costs $6 for the fence in the north-south direction. So that would be these, $6 per foot, $6 per foot, and $12 per foot for the east-west direction. What's the maximum area that can be enclosed? The farmer has a total of 1,440 to spend on the fence. Okay, well, we can start building functions like we used to. I know that area is equal to x times y, and I know that my total cost of the x's, that would be 3 times 6x plus, and then I have two of these pieces, 2 times 12y. 6x was the cost for the x parts, 12 was the cost for the y parts. Sorry, that should be a y. 12y equals 1,440. So if I solve that for y, I could solve that by saying this would be 18x plus 24y is equal to 1,440. I believe I can divide through by a 6 and get 3x plus 8y is equal to 2. That would be 40. Solve for y, and I get y is equal to negative 3/8 x plus 30. And then if I take that and plug it right in there, I would get area equals x times negative 3/8 x plus 30. Let's take that and plug it in the calculator. Pause while I do that. Okay, x times negative 3/8 x plus 30. Let's make sure I put the times in there. And alright. If I plug in 0 for x, I get 0 for y. Let's try to make a larger x max, maybe like 300, just a guess. Okay, I'm starting to see a curve. Let's make my x max larger by maybe like 200. Okay, don't need that big. Let's go back to 100. And my y max should be larger. My y max needs to be, let's see if I can select this. I might have to go the old fashioned. Nope, I can do this. Let's go maybe 500. Still not tall enough. 700. There we go. So I'm going to go to my window so you can see what my window was. There it is. And let's do a max. Menu, analyze graph, maximum, left bound, right bound. I have a maximum of 40, 600. So my vertex, I could say, was 40, 600. That means that when x is 40, my maximum area is 600. Question says, what is the max area? The max area is 600, and that would be feet squared. Number 6, suppose that the unit price, P, in dollars and the quantity X sold of a particular item satisfy the demand equation, and it gives the demand equation. P equals 200 minus X over 4. Find the price if 150 items are sold. So X is the number of sold and P is the price. I can just do this as P of 150 equals 200 minus 150 over 4. Which is 200 minus 75 over 2. 75 over 2 is 37.5. And 200 minus 37.5 is, I believe, 162.5. So the price is 162.50. Then part B, if the price is 75, how many items are sold? Well, then I would say 75 equals 200 minus x over 4. Swapping things around, I have x over 4 is equal to 200 minus 75, which is 125. Multiply that by 4, and I get x is equal to 500. Sketch the graph. Okay, that's not too hard. What do I know about this? I know it's a line. You guys should see that as y is equal to negative 1/4 x plus 200. So if we're going to sketch, I have a y-intercept of 200. And I have an x-intercept of, do we know what the x-intercept is? No. So let's do it. Actually, it gives me a domain. It tells me it's in between 0 and 800. So I've already plugged 0 in. Let's plug 800 in. If I go 800, negative 1/4 times 800 plus 200, I get 0. That is the x-intercept. So we'll say this is 800. This is x and this is p. And just a linear function right there. That's a sketch of it. How many items should be sold to maximize the revenue, and what is the corresponding unit price? We don't have a revenue function. So let's make one. The revenue of x would have to be the price per unit, which we know is 200 minus x over 4, times the number of units sold, so just times x. Well, that's an upside down parabola, so if I wanted to sketch that graph, let's go into the graphing calculator. Let's do a new page, and let's plug this in as 200 minus x over 4. Oops. I already have parentheses. 200 minus x over 4. And then we'll do times x. And I have what should be an upside down parabola, but really, again, I can't see too much of it. So let's see. If I plug in 0 for x, I get 0 for y. I know that one of my roots is 200, so is 800, so let's bring this up to maybe 1,000 for x. Okay, there we see it coming down. And then let's make that something like 2,000. No, it needs to be much bigger. Let's try 10,000. Starting to get there. Maybe 100,000. Too big. Bring that down to 50,000. And there we go. Let's find the max value. I'm going to do a maximum. And I have 400, 40,000. Now if I'm going to do a sketch of this, I'm just going to do something like that, where my x-intercept is 0. I know that this x-intercept would be 800. And I know that because that comes from this graph here, where my x-intercept was also 800. If I plugged 800 into this, that would make that factor equal to 0. And then I've got a vertex up here, and I know that the value of the vertex that I just found on that graph is 400. And then that max price is 40,000. So there's a little sketch. How many items should be sold to maximize the revenue? And what's the corresponding unit price? I know that 400 items should be sold. And the price is P of x, it's not R of x. So don't plug it into the R of x. Should be sold. I know I need to plug it into P of x. That would be, to do this work over here, 200 minus 400 over 4 gives us 100. Should be sold. The cost, or the price per unit is $100. So I use the revenue function to find the number of items, and then I use the price function to find out what the price would be. Number 7, we have an athletic field constructed in the shape of a rectangle with semicircle. We've seen this before. The perimeter of the field is to be a quarter-mile running track. Find the dimensions of R and X that yield the athletic field with the greatest possible area. So area is going to be equal to, I know it's equal to pi r squared because we have the two semicircles, then plus 2r times x, because really that length is 2r. Then we have to figure out, it says the perimeter of the field is 1/4 of a mile. Well, if we do our units in miles, I could say 1/4. So it says the perimeter is 1/4 of a mile. A mile is 5,280 feet, and half of that is 2640, and half of that is 1320 feet. So since we're going to assume that we're going to talk in feet, I'm going to say 1320 is equal to the perimeter of, that'd be 2x plus 2 pi r. That means I can cut that equation down into, that'd be 660 is equal to x plus pi r. And if I do 660 minus pi r, I can replace that with x, or I can set that equal to x and substitute that in. So I get area with relation to r is equal to pi r squared plus 2r times 600 minus pi r. I'm going to go ahead and pause and plug that in. I get a graph like this. So let's try to figure out what better x max could be. Let's try 100. Try 1,000. Okay, there it is. So let's go back to 500. Then let's try a y max of 1,000. Nope, need to go 10,000. Maybe 100,000. And almost there. Let's do 150,000. And we've got it. Move this up a little bit to give you a view of the axis. I'm going to pause on the window so you can see the window. Remember that scientific notation where you see the e plus 5. So that is really 140,000. Okay. So then let's do an analysis of the graph. Maximum. And I get 190.99 for my dimension for r. So my max area, it says it just wants the greatest maximum area, so we don't even need to see that. My r would be equal to 190.99 feet. And then x is equal to 600 minus pi times 190.99. So if I sort of say, all right, well, let's go back to a calculator, and 190.99 times pi. Then I wanted to do 600 minus that, so and as I'm trying to figure out what's going on here, I realized that if I took the full unrounded value that I've stored as s here, and I did 600 minus s times this pi, I get a number that's really tiny. I basically get 0. So the maximum area actually occurs when x is equal to basically 0. Now what does this mean? Well, this means that the maximum area track that would have to happen would just be a circle with the maximum radius that you could possibly have. And this kind of makes sense if you really think about it, because anytime we start going oval, we start losing area, and we lose area, and we lose area. But if we want the maximum area, we're just going to be a circle. So this is an interesting one. It taught me that, and I actually did learn this just now, because I made this worksheet up this year, and I didn't have it in previous years. But I learned that the athletic field with the greatest possible area for a track would just be a circle. Last one, number 8. Manufacturer finds that the revenue R earned on the production and sale of n items is given by this function. It's not a clean function, so just think we're going to be doing calculator. Keep in mind that a negative number of items cannot be produced. And n is the number of items, sale of items given. So, okay. Assuming that the manufacturer will stop production when the revenue becomes negative. Sketch the graph of the function R of n. Okay, I'm going to sketch by graphing graph and calculator. Pause. Got this. I'm going to move this so I don't have any real need in the x-axis, but I still need to increase the x-axis. Let's go up to, I tend to start going, let's try 1,000, too big. Let's go 100. No, it's not too big. It's starting to curve up. It's going to be a while before it curves down. Let's maybe make this be 1,000. See how tall it goes. Okay, that's way too tall. Let's go back down to 150 maybe. Let's take this out to 1,000, and let's bring this up to 300. Okay, now this is going to have to go up really high. Let's go up to 1,000. Maybe break this out to 3,000. This is going to be a while. There we go. Starting to get the arc coming. So let's bring this maybe out to 10,000. Okay. Now I've got a good view of it. Make that 3,500. So moved it up a little bit, but I'm going to go to Menu and let you look at my window. There's the window, and let's see what it's asking. It wants a sketch. So oddly enough, we know that the sketch is going to look like an upside-down parabola with the center at 0, 0. Can we figure out some critical points here? I know that that's 0, 0, but let's confirm it. Let's do a analyze graph and get my zeros. I'm going to go left bound, right bound here, and I have 0, 0. And then I'm going to do another analyze graph, 0. Let's do a left bound, right bound here, and I have this point at 7800. So that is at 7800. Oops. And that's at 0. My maximum is going to occur halfway between 0 and 7800, so I'm pretty sure that would be at 3900. But let's figure out what the maximum revenue is. So I'm going to do a max analysis. And I have my max 3900, 3042. So I'm going to write that as an ordered pair, 3900, 3042. How many items can the manufacturer produce and not have negative revenue? That would be this many, because that's your x-axis. You remember, n is the number of items. So we could say 7800 items was the most. That's where you have 0 revenue. But any more than that, and you start having negative revenue. Then it says compute R of 7,000. Okay, remember, you guys can go into the alpha y equals, alpha y1 and do y1 of 7,000. You can also do a second calc value. I'm going to show it a number of ways here that are going to mimic that. I go trace, and I actually just type in 7,000. Press enter, and then it tells me 11. Oh, see, as soon as I move it, I lose it. Let's try 7,000. You can see down at the bottom right it says 7,000, and then 1120. So I know that R of 7,000 is 1120, and that's $1120. Let's do it a different way. This function is stored right now in F10. No, it's in F9. So if I go to a calculator and I pull up and recall my F functions, I go to F9. I can just say F9 of 7,000. I get 1120. Again, you guys would hit alpha, one of the function keys at the top. Look for it and you'll find your y1, and you can do y1 of 7,000 if you have the function entered into y1. D, what is the maximum possible revenue? So let's go back to the graph and do a max. We already did it. It's 3042. So maximum possible revenue is 3,042 for how many should be manufactured and sold for selling 3900 items. And that's it.